this is your Kalpana here. So in this video we are going to see a problem from coordinate geometry. Okay, problem a minus 3 comma 2, b 3 comma 2 and c minus 3 comma minus 2 are the vertices of the right triangle. Right angled at A. Show that the midpoint of the hypotenuse is equidistant from the vertices. Okay. Solution. So we are given A, B and C are the vertices of a right triangle, right angled at A. Now consider a right triangle. Okay. Right angled at A. Okay. So you're having vertices A, B and C. A equals to minus 3 comma 2 and B 3 comma 2 and you're having C minus 3 comma minus 2. Show that the midpoint of the hypotenuse. So this is a hypotenuse, right? BC is a hypotenuse. The midpoint of BC is equidistant from the vertices. So how many vertices we are having? A, B and C, right? So we have to show that midpoint of BC and B is equals to midpoint A, midpoint C are equal. Okay. So let me name it as M, midpoint as M. Okay, midpoint of BC as M. So here we have to show that CM is equals to AM equals to BM. Okay, fine. So given vertices of the right triangle are A minus 3 comma 2, B 3 comma 2 and C minus 3 comma minus 2. Okay, right angled at A. Okay, so here we have to show that the midpoint of the hypotenuse, which is BC, is equidistant from the vertices. Okay. So let us find the midpoint firstly. We know that midpoint MXY is given by x1 plus x2 by 2 comma y1 plus y2 by 2. Now we have to find the midpoint of BC. Midpoint of BC is equals to, consider it as x1 y1 and it as x2 y2. Now apply the formula. So you're having x1 equals to 3 plus x2 equals to minus 3 by 2, y1 is 2 plus y2 is minus 2 by 2, which is equals to 3 plus into minus. So you'll get 3 minus 3 by 2 comma 2 plus into minus to 2 by 2. So 3 minus 3 is 0 and 2 minus 2 is 0. So you'll get 0 by 2 comma 0 by 2. 0 by anything is 0 except infinity. Okay. So you'll get 0 comma 0. 0 by 2 is 0. 0 by 2 is 0. Okay. So you have 0. So the midpoint of BC can be considered as O 0, 0. Okay. Now we have to show that OC equals to OA equals to OB. We have to show that the midpoint is equidistant from the vertices, right? We have to show that the midpoint of the hypotenuse, we have given a name, right? Say O is equidistant from the vertices. Okay, that is, we have to show OA equals to OB equals to OC. Okay. Since we know that the distance between 2 points is given by D equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Now we are going to find the distance OC, OA and OB. So let's find OC first. OC. Okay. So 0, I'll consider it as x1, y1, y2. Okay. So x2 is 0 minus x1 is minus 3 whole square plus y2, you're having y2 equals to 0 minus y1 is minus 2 whole square. Okay. So this equals to square root of 0 minus into minus plus 3 whole square plus 0 minus into minus plus 2 whole square. Okay. So this equals to square root of 0 plus 3 is 3. So you'll get 3 square plus 0 plus 2 is 2. 2 square. Okay. So this equals to square root of 3 square is 9 plus 2 square is 4. So 9 plus 4 is 13. So you'll get square root of 13. Okay. So the distance between OC distance between 2 points OC is square root of 13. Okay. Fine. Now let's find the distance OA. Okay, therefore OC equals to square root of 13. Now you need to find OA. OA equals to square root of, okay, consider it as some x1, x2, no, y1, x2, y2, okay. So x2 equals to 0 minus x1 is minus 3 whole square plus y2 is 0 minus y1 is 2 whole square, okay. So this equals to square root of 0 minus into minus plus 3 whole square plus 0 minus 2 is minus 2 whole square. Again you'll get 0 plus 3 is 3 square minus 2 whole square is plus 2 whole square, minus to minus is plus. So you could write it as 3 square is 9 plus 2 square is 4. Again you'll get square root of 13. So the distance OA, is square root of 13. Okay, so therefore OA equals to square root of 13. Now we'll find distance OB. OB or BO, anything. Okay, so 3 minus 0 whole square plus 2 minus 0 whole square. X1, okay, you have to write. You can write x1 minus x2 whole square or x2 minus x1 whole square. Nothing will change, okay? So I wrote 3 minus 0 whole square plus 2 minus 0 whole square, which is equals to square root of 3 minus 2 whole square is 3 square plus 2 minus 0 whole square is 2 square. So 3 square is 9 and 2 square is 4. So finally we'll get square root of 9 plus 4, 13. So therefore OB equals to 13. Okay. OB equals to square root of 13. Okay. Therefore, OA equals to OB equals to OC equals to square root of 13, which is nothing but the distance OA equals to distance OB equals to distance OC, which is nothing but the midpoint O is equidistant from the vertex A, and the midpoint O is equidistant from vertex C, and the midpoint O is equidistant from vertex D, which is nothing but the midpoint of the hypotenuse. BC is a hypotenuse, right? O is a midpoint. So the midpoint of the hypotenuse is equidistant from the vertices. Vertices C, vertices A, and vertices B. Okay. Therefore, the midpoint of the hypotenuse is equidistant from the vertices. Okay, this completes the problem. So we have seen a problem from coordinate geometry. Hope you will understand. We'll see you in the next video. Until then, bye bye.